Hello, so good afternoon. Today I will be sharing with you um, how can we do the pre-processing and sequence data variant calling workflow using Galaxy. So here we have a documentation how to do the basic variant detection. So here we'll just do the basic variant detection using Galaxy. Usually uh, this takes a while, so we'll just be showing you how or where are the tools. So first we go to the Galaxy. So I hope you can create your own. Um, I hope you can create your own account for this. So as you can see, I've already done some. So in the Galaxy, you can upload your data. So you can upload your sequences here. So for me, so there, these are my sequences. Normal sequencing data is quite large. So it's advised, for example, this one is around, let's see, properties size 15 kilobytes. Yeah, so this is around uh, 14.5 gig. So it's a big data. Uh, so first we have in sequencing there unidirectional sequencing and a paired end sequencing. So with my data, I have a paired end sequencing. That means for a certain fragment, the amplification is the read is from forward and reverse. That's why it's paired end, because there's a forward and a reverse reading of it. Okay, so you can upload your data there. With me, I have already um, uploaded my data here. So M1, W2, M1, M2. Okay, and from that you can actually try to check the quality uh, of your sequences. So you can do FastQC there. Then you will be uploading your sequences here, and you can already try to check the quality score. So here, FastQC. So we can try to visualize. So for example, let's try to visualize this raw data. View data. Ayan, okay. Okay, so this is the FastQC report. It will show you the quality score of per base. So as you can see, if it's in the green line, it's still really good. So the quality is good. So most of it are good. So here we'll see different quality scores per base sequence content, per sequence GC content, per base N content. So after checking the quality, you can do alignment. So to do alignment, we use BWA-MEM, BWA-MEM. So map with BWA-MEM. So here we try to so BWA means Barrows-Wheeler alignment. Barrows-Wheeler alignment. So here we try to align the FASTQ, this one, the raw sequences. We try to align the raw sequences with each other and with a reference genome. So you need 3 inputs, the paired end and the reference genome. After that, you would probably have around 50 to 60 gigabytes of raw data. So after doing that, you can also try to do some processes. So there are a lot of things that we can do in between, but consequentially, what you need is a BAM ready, analysis ready BAM file, and you will get that from the BWA mem. And after that, you will be doing freebase. So this is just a general overview. And you can do freebase, and from here you can detect variations within the genome. And from that, from the variations that you will be producing or that you will be detecting, you can now predict the single nucleotide polymorphisms and insertion deletion changes that happened in your genome, in your dataset. After that, you can do further analysis and identify interesting genes that may be the cause of the change in the appearance of your plant. For example, your plant became you are comparing a normal plant and a plant that that doesn't have many branches. So with that, you can with the variation that you've detected, you can try to correlate which SNPs, which insertion deletions are responsible for the changes that happen in your plant. Okay, so this is a website where you can do the detection and the okay. So let me introduce first the GATK. So here in this website, it gives you the main workflow of how to do variant calling. So this is the usual workflow. So here, sorry. This one. So this shows you the usual workflow of how to do the variant calling. So first you have raw and mapped reads, then you try to map map this to the reference and the raw the mapped reads. Check for the mark duplicates, recalibrate base quality scores. This recalibration requires some neural network, but JTK workflow will take care of that. Then after that, you can have your variant calling. Then further, you need to filter, refine, and annotate your variants. So it's a lot of process. But this website also shows how to actually do it outside Galaxy. Okay, so for example, if we search for uh, so here they have already the haplotype caller in GBCF mode. We can so if ever you are interested in doing the variant calling using Galaxy, you can also check this website. The problem with Galaxy is that you have a limited memory. So as you can see, you have a limited memory. So I'm already at 63% and I've just uploaded around 159 gig. So if you have a lot of samples, if you have 5 samples, you wouldn't be able to run anything significant in Galaxy. So the the capacity of Galaxy is very limited. That's why if you can do it in your terminal, it's much better.